So our next topic is the Maxwell's loop currents. So this method, which is particularly well suited to coupled circuit solutions, employs a system of loop or mesh currents instead of branch currents as in Kirchhoff's laws. So here the currents in different meshes are assigned continuous paths so that they do not split at a junction into branch currents. So this method eliminates a great deal of tedious work involved in the branch current method and is best suited when energy sources are voltage sources rather than current sources. Basically, this method consists of writing loop voltage equations by Kirchhoff's voltage law in terms of unknown loop currents. So in short, this Maxwell's loop current employs loop or mesh currents instead of branch currents. So we will use loop currents, closed loop, and Maxwell's loop current is the simplified Kirchhoff's voltage law in terms of unknown loop currents. So here we have an example. This example is one of our examples in Kirchhoff's laws. So we will use the Maxwell's loop current to solve the branch currents of this circuit. So we have a battery EA and EB, 26 volts and 24 volts. And internal resistance of the battery, 24 volts, is the 0.4 ohm. Also, the battery has an internal resistance of 0.4 in battery B. And our load here has a resistance of 0.8 ohms. So first, we will assign loop currents in this circuit. So first, we will use the same direction of loop currents. Later on, we will solve also the opposite loop currents. So we will let this closed loop to be our loop I1, and the other loop, closed loop, is our loop current I2. Okay, now what we will do here is to assign in our resistances. So we have here positive, negative, and as you can see here at the middle, we have two loop currents acting on RL. So what we do is we take this positive, negative here, and also the other side is negative, positive. So in here we have the I1 and I2 to be in the same direction, where the branch circuit current in RL, the current flowing here, will be the difference between the loop current I1 and I2. So we will deal on that later. Now we are ready to formulate the loop equations of loop currents I1 and I2. So for loop current I1, the loop current entering to the negative sign of a battery. So we have a voltage gain here. So positive 24 And then, loop current I1 entering into a positive sign of the resistance RA. So we will have a voltage drop in our RA to be negative. So negative 0.4 I1. And then, again, entering into a positive sign of RL 0.8, we have a negative 0.8 IL. So we already discussed this one in Kirchhoff's voltage law, yung signs ng IR drops and the battery. And then, for I2 here, since RL has two loop currents acting on it, so we will have the I2 entering into a negative sign of the RL. So we will have a positive drop. We have 0.8 I2 is equal to 0. Simplifying this equation, we will have 24. So 0.4 I1. This is I1, not IL. 0.4 I1 minus 0.8 I1, we will have a negative 1.2 I1 plus 0.8 I2 is equal to 0. So this will be our equation 1. Or, pwede natin kunin yung I2. So I2 will be equal to positive 1.2 I1 minus 24 divided by 0.8. So this will be our equation 1. Again, don't forget to equate your equations in 0. So, estimate lang. Next loop, we have loop I2, loop current I2. Dito na lang. So, for loop current I2, we have here the loop current I2 entering to the positive sign of a battery. So, we'll have a voltage drop in that. So, we will have negative 26. And then, loop current I2 entering to a positive. Ito namang side na to for loop current I2. The other side was in loop current I1. So, loop current I2 entering into a positive sign of RL. So, we have a negative 0.8 I2. And then, the I1, loop current I1 here entering to a negative sign. So, we will have a positive 0.8 I1. Another drop in RB. So, loop current I2 entering to a positive sign of RB. So, we will have a negative 0.4 I2 is equal to 0. Simplifying this equation, we will have negative 26. So, 0.8, 0.4, we have negative 1.2 I2 plus 0.8 I1 is equal to 0. So, this will be our equation 2. So, equation 2. Substitute equation 1 in 2. 1 in 2. So, we have negative 26 minus 1.2 multiplied by 1.2 I1 minus 24 divided by 0.8 plus 0.8 I1 is equal to 0. So, multiplying both sides of the equation by 0.8, negative 26 times 0.8 is equal to negative 20.8. Then, 0.8 cancel. We have minus 1.2 times 1.2. So, negative 1.44 I1. Negative. So, we have positive 1.2 times 24. Positive 28.8. 0.8 times 0.8 is equal to 0.64. I1 is equal to 0. So, negative 20.8 plus 28.8, that is equal to 20. Negative 1.44 plus 0.64 is equal to 0.8. So, negative 0.8 I1 is equal to 0. So, solving loop current I1, we'll have 20 divided by 0.8, so that is 10 amperes. Positive answer, so that means your loop current direction is correct. Next, we will solve your I2. We will use equation 1 to solve for I2. So, I2 is equal to 1.2 I1 minus 24 divided by times I1 is 10 minus 24 divided by 0.8. So, I2 is equal to negative 15 amperes. So, negative, or we will have 15 amperes. Dapat ganito yung direction ng loop current natin. So, tama pa rin. Now, what will be the values of your branch currents, IA, IB, and IL? So, as you can see here, the loop current flowing in RA is your I1. So, this one, dito ti IA yo. And then, IB. This is your IL. So, the loop current flowing in RA is equal to our loop current I1. And the loop current flowing in our RB, which is our loop current I2. Therefore, in our final answer, our IA is equal to the loop current I1 is equal to 10 amperes. Branch current IB is equal to the loop current I2, which is equal to negative 15 amperes. Now, our IL is equal to the difference of loop currents I1 and I2. Okay? So, I1 is 10 minus negative 15 is equal to 25 amperes. So, next, we will solve same problem but we will use the opposite direction for I2. Tignan natin kung magiging positive na yung I2. Now, we will try to solve the loop current I1 and I2 using Maxwell's theorem or loop current. So, as you can see here, the loop current I1 and loop current I2 are in different direction. For loop current I1, it is clockwise and I2 is anti-clockwise direction. So, the sign in your RL will be at the I1 side, positive, negative, and also at the I2 side is positive, negative. So, how will you determine the sign here if there are two loop currents acting on a resistor? So, kasta. No, anay ti nagserkan ni tail. So, this is your tip of the direction, and this is your tail. Kung sino tinagsarekan ni tail, it is your positive. Ti pagliban na is your negative. So, a while ago, di ba, the direction of current tayo ket same. So, tinagsarekan ni tail dito is positive. Kung ilikos mo deta, positive, negative. And also, the I2 is from here. So, positive, negative. So, we will now formulate the equations of I1 and I2. So, I1, loop current I1 from here, or mangrugitay ito'y source. So, loop current I1 entering into the negative sign of a battery. So, we'll have positive 24. And loop current I1 entering to the positive sign of RA. So, you will have negative 0.4. I1 entering to positive of RL. So, you will have negative of 0.8 I1. Simultaneously, your I2 will be equal to, so, loop current I2 entering to the positive sign on this side. So, you will have negative 0.8 I2 is equal to 0. So, simplifying this equation, we will have 24. Same I1, so negative 1.2 I1 minus 0.8 I2 is equal to 0. So, getting the equation of I2, you will have 24 minus 1.2 I1 divided by 0.8. So, this will be our first equation. Next loop, we will have loop current I2. So, what will be the equation of your loop current I2? So, datimet nga side din. Mangrugitay J battery. So, entering into the negative sign of the battery, we have positive 26. So, this is for loop I1, loop I2. And then, this will be your positive, negative. Minus 0.4 I2. This loop current entered into the positive sign of RB, so you will have negative 0.4 I2. And then, loop current I2 entering into the positive sign of RL on this side. So, you will have negative 0.8 I2. And also, your I1, loop current I1 entered into the positive sign of RL. So, minus 0.8 I1 is equal to 0. Simplifying now the equation, 26 minus 1.2 I2 minus 0.8 I1 is equal to 0. This will be our equation 2. Substitute 1 in 2. 26 minus 1.2 times 24 minus 1.2 I1 divided by 0.8 minus 0.8 I1 is equal to 0. So, multiplying both sides by 0.8, 26 times 0.8 is 20.8. 1.2, negative 1.2 times 24 is equal to negative 28.8. Negative 1.2 times negative 1.2 is equal to positive 1.44 I1 minus 0.8 times 0.8, that is negative 0.64 I1 is equal to 0. So we will get 1.44 minus 0.64, that is equal to 0.8 I1 minus 8 is equal to 0. Solving for I1, 8 divided by 0.8, so that is equal to positive 10 amperes. So, loop current I1 is equal to 10 amperes. Solving for loop current I2, we will just substitute it in equation 1. So, I2 is equal to 24 minus 1.2 times 10 divided by 0.8. That is equal to 15, positive 15 amperes. So, our assumed direction of loop currents are both positive. That means we have assumed the correct direction of loop currents. So, our final answers, the branch circuit currents. So, for branch current IA, IB, and IL will be equal to IA, the loop current flowing in IA, is equal to the I1. Loop current flowing in RB, that will be your I2. And the equation or the loop current in RL will be the sum of I1 and I2 because they are in same. So, agpada dati nga simrek ijay RL. So, this will be the direction of your IA. Hindi makita. Ito yung direction ng IA. Direction ng IB. Branch current IB and direction ng IL. So as you can see, the direction of IL is the same direction in I1 and I2. So ag plus ni I1 ken ni I2. So branch current IA is equal to loop current I1, branch current IB is equal to the loop current I2. So this is 10 amperes, 15 amperes, and IL is equal to the sum of I1 plus I2. So that is equal to 10 plus 15 is equal to 25 amperes. They are all positive. So second example, this was one of our examples also in Kirchhoff's, but we will try to solve this using Maxwell. So we will solve the branch currents in this circuit using Maxwell. So I already set the direction of currents. For this loop, I will name it as I1. So it is a clockwise direction. I2, anti-clockwise, and I3 is the clockwise direction. So setting up the polarities of your resistors. So if this is our direction of current, so this will be the positive kasi iso tinagserekan ni tail. And also, this will be positive kasi iso man tinagnaan ni tailen. I2, same true with this. Positive here, and also I3, positive here, and detoy. Okay? So, positive here kasi no, iikot mo detoy, sumrek ditoy. So, this will be positive. We'll formulate now the equations of your loop currents I1, I2, and I3. But before that, what will be the values of your I1? Diba, current flowing in R1 will be I1. So, this will be the direction. This is I1 since this is R1. R2, this is the positive. So, pakastoy. This is I2. And I3 will be here. IA, downward. And IB is upward. IB. Therefore, the value of your branch current I1, so this is branch, this is loop, is equal to loop current I1. Branch current I2 will be loop current I2. Branch current I3 will be loop current I3. And IA, branch current IA, it is equal to the sum of your I1 and I2. Same lang mean positive, positive. And then, branch current IB will be also the sum of I2 plus I3. Loop current I2 and I3. Formulate now our equation for loop current I1. So, loop current I1. Entering into the negative sign of battery, we will have positive 120, then minus 1.5 I1, minus 21 I1, and also our I2 is entering to a positive sign at this side, so minus 21 I2 is equal to 0. So, simplifying this equation, we have 120 I1, so that is equal to negative 22.5 I1 minus 21 I2 is equal to 0. So, we will get the value of or equation of I2. So, I2 is equal to 120 minus 22.5 I1 divided by 21. So, this will be equation 1. Loop current I2. At equation T, loop current I2. So, starting here at the top. So, entering into a positive sign of R3, we will have negative 3 I2. Entering into a positive sign of RA, so minus 21 I2. And then your loop current I1 will be entering into the positive sign also of RA, so minus 21 I1. Loop current I2 entering into the positive sign of RB, so minus 6 I2. And also, loop current I3 entering to the positive sign of RB at this side. So that is equal to minus 6 I3 is equal to 0. Simplifying the equation. So I2, we will have negative 24 I2 minus 21 I1. Meron pa pala dito. So, 6 plus 24, so this is 30. Negative 30 I2 minus 21 I1. And then minus 6 I3 is equal to 0. Loop current I3. So, formulating loop current I3. It enters into the positive sign of your battery, so that is equal to negative 105. And then, entered into a positive sign of RB minus 6 I3. Your I2 entered also in a positive direction, positive polarity of RB on this side. So, minus 6 I2. And then, your I3 here entered in positive. So, that is equal to negative 1.5 I3 is equal to 0. So, 105, negative 105 minus 6 I3 minus 7.5. This is I2. Negative 6 I2 minus 7.5 I3 is equal to 0. So, let us go back here. In equation 1, So, I1 na lang yung kukunin natin dito para yung I1 in terms of I2. So, if we will substitute I1 here, we will get in equation 2 to be in terms of I2. And then we will formulate or get also the equation of I3 in terms of I2. And then, isa-substitute na naman natin dito sa I2, equation 2 para maging I2 lahat tong equation 2. So, in our equation 1, we will get I1 na lang. So, I1 is equal to 120 minus 21 I2 divided by 22.5. So, this will be equation 1. I3 is equal to, in our loop current I3, negative 105 minus 6 I2 divided by 7.5. This is our equation 3. So, we will substitute equation 1 and 3 in 2. Substitute 1 and 3 in 2. So, negative 30 I2 minus 21. I1 is 120 minus 21 I2 divided by 22.5 minus 6 I3. So, our I3 is negative 105 minus 6 I2 divided by 7.5 is equal to 0. So, lahat na in terms of I2. So, we will multiply both sides by 22.5 and 7.5. So, 22.5 times 7.5 times 30 is equal to 5,062.5 I2. And then, next term, so cancel tong 22.5 dito, tsaka yun. So, 7.5 times 21 times 120 is equal to negative 18,900. Next is negative 21 times negative 21, so that is positive, times 7.5. So, 3,307.5 I2. Next, 7.5 cancel. So, you will have 22.5 times negative 6 times negative 105. So, that is positive 14175. Negative 6 times negative 6 times 22.5. So, positive 810 I2 is equal to 0. This is negative. Combining all the like terms, negative 5,062.5 plus 3,307.5 plus 810 is equal to negative 945 I2. negative 18,900 plus 14,175 is equal to negative 4,725 is equal to 0. So, solving for I2 is equal to negative 5. I2, loop current I2 is equal to negative 5 amperes. Solving for I1, substitute the value of I2 here in equation 1. You will get 120 minus 21 times 5 divided by 22.5. That is equal to negative 5 times negative 5. Positive 10 amperes. Next is I3. Substitute in equation 3. So, negative 105 minus 6 times negative 5 is equal, divided by 7.5 equal to negative 10 amperes. Therefore, our branch currents will be equal to I1 is equal to negative 5. I2 is 10. Ay, baliktad. I1 is 10. I2 is negative 5. And I3 is equal to negative 10 amperes. IA is the sum of I1 and I2. So, 10 plus negative 5 is equal to 5 amperes. And also, IB is equal to the sum of I2 and I3. So, negative 5 plus negative 10 is equal to negative 15 amperes. So, the direction of I2 para maging positive siya is clockwise. Same is true here in I3 or 10 amperes anti-clockwise direction para maging positive din tong IB. Okay? So, try to solve the branch currents using the determinants or the Kramer's rule. So, mas madali yun kasi mag-input lang kayo ng mga values. And using matrix, Kramer's rule, makukuha nyo na yung mga loop currents, I1, I2, and I3.